Before there was light, there was only silence. Not the silence of a night sky, nor the quiet of an empty room, but the deep, ancient stillness of a universe unborn. In those first hundreds of millions of years, space was a vast, invisible ocean. No stars burned, no galaxies spun. Only a dark haze of hydrogen drifted through the expanding void, unbroken by any spark. Time itself moved without witness, carrying the cosmos toward a destiny it had not yet revealed. This was the cosmic dark age, an era where gravity and chance were sculptors, shaping clouds of gas into forms no living eye would see for billions of years. And somewhere, in the cold pressure of this darkness, the first embers of starlight were waiting to ignite. Then, in an instant measured not in seconds, but in the collapse of worlds yet unborn, the first stars were born, titans of fire, millions of times brighter than the sun, roaring into existence and ending the night. The universe had begun to shine. For eons their light raced outward, across the newborn galaxies, through the fabric of space-time stretched and thinned by the expansion of the cosmos. It would travel for 13 billion years, until at last it met the gaze of a fragile world, orbiting an ordinary star. To see that first light, to witness the birth of creation itself, humanity built a machine unlike any before. It would drift far from Earth's warmth, into the frozen silence beyond the moon, to stare deeper into the past than any human eye had dared. This is the story of the telescope, that saw the birth of the first stars. It began not with the light of the first stars, but with the limits of human sight. By the final years of the 20th century, the Hubble Space Telescope had been humanity's window into the deep universe for nearly a decade. Suspended high above Earth's atmosphere, it had captured breathtaking portraits of galaxies colliding, nebulae blooming, and planets in far-off systems casting shadows across their suns. Yet, for all its triumphs, Hubble faced a barrier that even its crystal optics could not pierce. It could not see far enough back, not to the true beginning. The reason was not in the skill of its engineers, but in the nature of light itself. The first stars, born hundreds of millions of years after the Big Bang, radiated in ultraviolet and visible wavelengths. But across the chasm of 13 billion years, the expansion of the universe had stretched that light into the infrared. By the time it reached us, it was no longer the light Hubble could detect. The earliest chapters of cosmic history lay hidden in a spectrum the great telescope was never built to see. Astronomers dreamed of a successor, a machine sensitive enough to capture the faintest whispers of that ancient glow. But what they envisioned would be more than an upgrade. It would be an entirely different kind of eye, tuned not to the light of the nearby universe, but to the dim heat signatures of the first galaxies, the first suns, and perhaps, if fate allowed, the first spark of starlight ever kindled. The idea took root in the 1990s. NASA scientists, alongside partners in Europe and Canada, began sketching plans for what they called the Next Generation Space Telescope. Its mission, to reach the cosmic dawn, the moment the first stars lit the darkness, and in doing so, illuminate a period of time no human had ever witnessed. This dream required audacity. To detect such faint light, the telescope's mirror would have to be enormous, far larger than anything that could fit inside a rocket fairing in one piece. The solution was radical. Build a segmented mirror, each hexagonal panel coated in pure gold to maximize infrared reflectivity, and fold it for launch like a delicate origami of glass and metal. It would also need to be cold. Not the cold of Earth's winters, nor even the chill of space just beyond our atmosphere, but a deep, relentless cold, mere degrees above absolute zero. Only at such temperatures could its instruments distinguish the faint warmth of the first galaxies from the telescope's own heat. To achieve this, engineers conceived a sunshield the size of a tennis court, layered like a silver sail to block light and warmth from the sun, earth, and moon. The vision was beautiful. The engineering, daunting. Years turned into decades. Budgets ballooned, schedules slipped, and doubts spread. Critics questioned whether such a fragile, complex machine could even survive the violence of launch, much less unfold flawlessly in the silent void. But the promise of its mission, the promise of seeing the birth of the first stars, held the scientific community together. In 2002, NASA officially renamed the project the James Webb Space Telescope, after the former NASA administrator who had guided the agency through the Apollo era and championed the science that followed. The name carried weight. This would not just be an observatory, it would be a time machine. Across continents, thousands of engineers, scientists and technicians laboured on its parts. In Maryland, the mirrors were polished with microscopic precision. In California, the sunshield was tested in clean rooms, each layer unfurling like a petal of alien silk. In Canada, the fine guidance system was crafted, a precision eye to keep the telescope locked onto targets billions of light years away. And in Europe, the Ariane 5 rocket was prepared to carry it into the darkness. The stakes were unprecedented. Unlike Hubble, which could be serviced by astronauts, Webb would be stationed far beyond the Moon, at the second Lagrange point or L2, a gravitational pocket of stability 1.5 million kilometers from Earth. Once it left home, there would be no return, no rescue mission. Every latch, every hinge, every bolt would have to work perfectly the first time. Failure would mean the loss of not just a telescope, but decades of human effort in the hope of glimpsing the universe's first light. In the months before launch, anticipation and anxiety intertwined. Scientists rehearsed observations that might reveal ancient galaxies never before imagined. They wondered what they would see, and feared what they might not. Would the first stars be too faint? Would cosmic dust veil them from view? Would the great machine, after all this time, return only silence? And then, at last, the day came. December 25th, 2021. A Christmas morning in Kourou, French Guiana. The Ariane 5 stood poised on its launch pad, the gold of Webb's mirror hidden within its nose cone. Clouds drifted in the tropical air. Around the world, astronomers gathered in homes, offices and observatories to watch the countdown. At ignition, flame and thunder tore through the humid air, lifting the telescope skyward. In minutes, the rocket left Earth's atmosphere, carrying Webb toward the vast, cold darkness that would be its home. But launch was only the beginning. Over the next month, in a slow ballet of precision engineering, the telescope unfolded. The sunshield stretched taut across its 5 layers. The mirror's segments locked into place, each reflecting the faint light of distant stars. Cooling systems hummed, instruments powered on, and alignment began. Every step was a gamble. Any misstep, a snagged shield, a frozen hinge, could end the mission. Yet one by one, the deployment succeeded. Humanity's new eye on the universe was opening. In the control rooms and laboratories across the globe, scientists held their breath. The telescope was ready. The first deep sky targets were chosen. Light that had been travelling since the dawn of time was about to fall, at last, into human hands. The journey to witness the birth of the first stars had moved from theory and engineering into reality. What lay ahead was not just a technological triumph, but a confrontation with the oldest light in existence, light that had waited billions of years for this moment. For months after launch, the James Webb Space Telescope drifted in the cold quiet of deep space, its mirror aligned, its instruments tuned, its sunshield holding back the warmth of the sun. It was ready, but readiness was not enough. The true test lay ahead, catching the oldest light in the universe and making it speak. The first public unveiling was not just a photograph, it was a portal. On July 12, 2022, NASA revealed Webb's first full-colour deep-field image to the world. At first glance, it seemed almost like Hubble's famous views, a canvas of black scattered with galaxies, some spiralling like pinwheels, others glowing as soft red smudges. But then the scale became clear. Every arc, every smear of light was not a star, it was an entire galaxy, each with billions of suns, and some of them were impossibly ancient. They were so far away that their light had been travelling for over 13 billion years, light born when the universe was less than 1 billion years old. Yet here they were, sharp and defined, their colours stretched into the deep reds and oranges of extreme cosmic redshift. For scientists, this was both exhilarating and unsettling. These galaxies were too massive, too luminous, too evolved for their age. According to established cosmological models, galaxies in the universe's infancy should have been small, irregular
Today,
and faint,
NASA's James
mere
Webb
beginnings
Space
of the
Telescope
giants we see
amazes
today.
us with its new views of the
But
universe.
Webb was showing something else. Fully formed structures,
But its images
bustling with
build upon
stars,
40
emerging
years of
much sooner
innovation
than theory
in
had
infrared
allowed.
space telescopes.
This was the first jolt of the shock. The second came in the weeks that followed,
measured the
using
infrared
Webb's
glow
near-infrared
of hundreds of thousands of
spectrograph,
stars and
NRSpec.
galaxies.
Astronomers began analysing the spectra of these distant
In
objects.
2003,
Spectroscopy
the
is a
Spitzer
truth
Space
teller.
Telescope
It reveals
began
the
a new
fingerprints
era
of elements
infrared
and the
astronomy.
precise distances to cosmic objects.
Spitzer
What the
revealed
data
details of
confirmed was
galaxies and
stunning.
nebulas
Some of
never
the
seen
candidates
before.
were from just 200 to 300 million years after the Big
Now
Bang,
Webb takes
right
us
at the edge
even
of what we
deeper
call the
into
cosmic
infrared
dawn.
universe.
It was as if a curtain had been pulled back on the first act of creation, and instead of a dim, tentative beginning, there was already a thriving stage
We
of
look
cosmic
forward
life.
to the wonders yet
But
to
the
be
shock went
revealed
deeper
by
still.
Webb.
In
And
some
future
cases, the
infrared
number of
telescopes.
stars in these galaxies implied that star formation was happening at rates 10 times
NASA has
higher than
captured a
expected for
new
such early
infrared
events.
image of the center
This was
of
a
our
problem,
Milky Way
a
galaxy,
beautiful problem,
revealing
because it
details
forced
that have
astronomers
never
to
been seen
question their
before.
models of how matter clumped
Scientists
together
have
in the early
tried for
universe.
many years to peer
Could
through
it
the
be that
dense
dark
swirls of
matter,
dust obscuring
the invisible
many of the
scaffolding
Milky
of the
Way's
cosmos,
fascinating
was more
features.
efficient in drawing gas
Sophia,
together than we
NASA's
thought.
telescope on an
Or something
airplane,
in our
observed our
understanding of
galaxy's
cosmic
center in
inflation, the
infrared
rapid
light,
expansion after
which
the
is
Big
invisible
Bang
to
sucked
human
the world.
eyes but
There was
pierces
another,
through the
even more
dense
tantalizing
dust.
possibility.
Now we
Webb
can
might be
see
seeing
new
not just
details
early
in the
galaxies,
curves
but even
surrounding
the
the
first stars
Arches
themselves.
cluster,
The
the
long
densest
theorized
concentration of
population
stars in our
These would have been
galaxy.
colossal,
Also
burning
visible
hotter and
is the
brighter than
quintuple
any that
cluster,
followed,
with
composed
stars that
only
are a
of
million
hydrogen and
times
helium,
brighter than our
free from the
Sun.
heavier elements forged
Our
in
galaxy's
generations.
supermassive black
Short,
hole
violent
takes
lives
shape
would
with
have
a
ended
view
in
of the
tectonic
fiery-looking
supernova,
ring of gas
seeding the
surrounding
cosmos
it.
with the raw materials
NASA
of
created the
planets,
panorama
oceans,
by combining
eventually
Sophia's
life.
new, crisp
telescope
image
never seen
with
that.
previous data
The
from
Webb
the Herschel
sensitivity
and
meant it
Spitzer
might catch the
space
glow of entire
telescopes.
clusters of them,
Scientists
embedded
will
within
use
these
the
early
image to
galaxies.
study previously
confirmed
hidden facets of
to be
our
the
Milky
closest
Way
we've ever
galaxy,
come to watching the
including
universe
how
take
many
its very
massive
first
stars
breath.
are forming here,
implications
and to
were
set
staggering.
targets for telescopes of the
Standard
future
model of
like the
cosmology,
James Webb
a
Space
carefully tested
Telescope.
framework describing
That
the
whole
Big Bang,
process of
cosmic
galaxies
inflation,
forming
dark
and
matter,
evolving
and
over
dark energy
13+ billion
was not
years,
supposed to
we've learned
produce
a
such
lot about
mature
that, but
galaxies
we're
so
really
quickly.
missing a key piece
If
of
Webb's
We have a pretty
observations
good
held
idea that they
true,
were very much
something in
larger
our
than the
cosmic
sun,
recipe would
and
have
that
to
they would burn out
change.
in a tremendous
Perhaps
burst of
star
glow.
formation
They would
began
also
earlier than
prepare the way
thought.
for further
Perhaps
generations of stars
the
like the
first
sun to be
stars were
formed.
even more
So
efficient
those
in lighting
first
up the
stars would
universe
produce
than
the
models
chemical
predicted.
elements of life,
Or
carbon and
perhaps,
oxygen and
most
nitrogen and
unsettling of
iron and
all,
sulfur
there were
and
gaps in
calcium
our
and all the
understanding
things
of
that
the
we're made
physics
of
governing the
would
early
have been
universe.
produced in those first
In the
generations of
scientific
stars that
world,
then
such
explode and
challenges are
liberate
not
the material
failures.
back out into space.
They are the lifeblood of
So the
progress.
next generation
But in
of
the
stars
quiet moments
that form
after
with
the
planets
images were
with solid
revealed,
bodies
one could almost
possibly
feel the
have
collective
life.
gasp of a community, realizing that the universe they had studied
Understanding
for
the
decades
vast
was,
scale
in
of the
some
universe
ways,
is no
stranger
mean
than they had
feat.
imagined.
But Hubble
The
has
shock was
helped
not
us to
just
understand
intellectual,
the
it was
skies around
emotional.
us.
For
It has
decades, the
peered
cosmic
far away
dawn
to
had
the
been a
very
ghost,
edges of the
a
visible
place in the
universe,
timeline that lived only in
and taken
equations and
snapshots of
simulations.
space as it
Now,
appeared
it
deep
was
in the
real.
cosmic
The
past,
light from those first suns
billions
had
of
crossed
years
nearly
ago.
the entire age of the universe, slipping past galaxies,
It would take nearly
nebulae,
600
and the empty
years to
reaches
travel
of
out to
intergalactic
Neptune
space
at the speed
to
of an
finally
average
fall upon the
passenger
mirrors
jet.
of a machine made by
As
fragile
we
beings
can't
on a
travel
pale
to other
blue
galaxies or
world,
star systems
came
and view them
bearing
for
secrets.
ourselves,
Among
we
the most
rely on
profound was the
telescopes like
possibility that
Hubble.
these early stars and galaxies were not
One
just
of the
distant
main
in space,
scientific
they were
justifications
distant
for
in
building
time
Hubble
itself.
was to
By
measure the
observing
size
them,
and age
Webb
of
was
the
letting us see the
universe.
universe not as it is,
This task
but as
has
it was,
produced some of the
a living record
telescope's
of its
most
own birth.
iconic images,
In
taken
those
as
faint,
Hubble peered into
red-shifted
the faraway
smudges, we
universe
were looking at the moment
to see
reality
what
began to
galaxies
build the
look like
complexity
in the
that would lead
past.
inevitably to us.
Now normally,
The
in our
press
everyday
conferences
lives,
spoke of data,
it doesn't matter
spectroscopy,
because the
and redshift
distances are
numbers.
just too small.
The images spoke in
But
a
when we
different
look at the
language,
moon,
the
we see
language
it
of
as it
awe.
was about
For
1
the first
second
time,
ago.
humanity could see across almost the entire history of the cosmos, nearly to the moment the first starlight pierced the dark.
The sun we
Yet with
see
each
as it was
revelation,
about 8
the mystery
minutes ago.
deepened. How could so much
For the
structure
nearest
form
star,
so soon?
it's about 4
Were
years.
these truly the first
and the
galaxies?
edge of our
Or had we
galaxy
stumbled upon
we
something
see
even
as it was
stranger?
about
A population of
100,000 years
objects
ago.
that defied classification. Could we perhaps be seeing the fingerprints of
look
exotic
further,
physics at work in
These
the early
thousands
universe?
of years turn
For
into
scientists,
millions,
this was not
and
the end of
even
the shock, but
billions,
the beginning of an
right
urgent
back
investigation.
to when the universe
The
was
shock
very
of the
young.
first images had
We
barely
see
settled
these
when the work of
galaxies
true
as they were
investigation
in the
began.
very distant past.
The James Webb Space Telescope was not built to
Galaxies
deliver
near
pretty
to us
pictures
are fully
alone.
formed,
It was designed to
seen as
interrogate the
sleek
very bones of the
spirals and smooth
cosmos.
ellipticals.
And now it was time to
As
ask
we
the
travel
first stars
further
their
back,
names.
we see toddlers
Astronomers
that are
knew that
rough
finding
around
the
the
earliest
edges,
galaxies was only the
still
first
in
step.
the middle of
To
evolving
understand them,
into
they
fully
needed to
grown
pull apart their
galaxies.
light, to break it into spectra that would reveal their composition.
The images show some of the most
and
distant
age.
galaxies that have
This was
ever
the
been
realm where
observed,
Webb's instruments could
going
turn
back
beauty
an
into
incredible
knowledge.
13.2
Webb's
billion years,
near-infrared spectrograph,
to a time when the universe was only about half a billion years old.
The near-infrared camera, NIRCAM, became the primary
This
tools
far
for this
back in
cosmic
time,
autopsy.
Our Milky
The
Way
strategy
may
was
have
precise.
just formed.
Choose a patch
However,
of sky
the Earth
so
only
small
made an
it
appearance
could be covered by the
just
palm
under
of your hand, yet deep
8.5
enough to reveal
billion
galaxies
years
across
later.
nearly the entire
The
history of the
entire
universe.
history of the Earth
These were the
has
cosmic
taken
deep
place
fields,
over just a third
windows
of
into
the
the
universe's
abyss.
lifetime.
Hubble had pioneered this
From the
approach,
Earth's
staring for
formation
weeks into
to the
tiny,
emergence
seemingly
of
empty
dinosaurs,
regions of space
early life
to uncover
and
hidden
humans,
galaxies.
to the present
Webb,
day,
with its
where
far greater
astronomers use
infrared
Hubble
sensitivity,
to
could
view
do the
some
same
of the
in a fraction of the
universe's
time and
earliest
reach much further
inhabitants
back.
and
The
explore
process began
our
with target
origins.
selection. Teams combed through
Hubble
catalogues from
is
earlier
still
surveys,
searching the distant
hunting for
universe
faint red smudges
for
that
clues
might be
about how the
candidates for
universe
extreme
formed
redshift,
and how
the
it
telltale
has
stretching of
evolved.
light caused by the expansion
Several
of
of
the universe.
Hubble's surveys,
In
for
the early
example,
days, even
candles,
identifying these
flash,
candidates was a
and
matter of
goods,
careful
are
speculation.
scanning for distant
spectroscopy
supernova
confirmed them,
explosions,
they remained
objects that are
possibilities,
good
not
celestial
certainties.
distance markers.
Once the targets were chosen, Webb's instruments
Observations
locked
of
on.
distant supernovae
Infrared light that
led
had
to the
travelled for over
discovery
13 billion
that the
years
expansion
fell upon
of
its
the
gold-coated
universe is
mirror, was
accelerating,
focused through a system
which
of
earned 3
cryogenically cooled
astronomers
optics
a
and
Nobel
entered the
Prize in
spectrographs.
Physics in
There,
2011.
it was split into delicate
is to
rainbows,
see how
not the
planetary
bright bands of
systems
sunlight
got
on
their
Earth,
start.
but
So that would be
deep,
akin to
ghostly
thinking about
spectra,
how our
where
solar
each
system
dip and
was
rise
several
marked the
billion
presence
years
of
ago.
specific
So
atoms,
looking at the big
hydrogen,
disks
helium,
of gas
and in some
dust
cases the
that
faint
eventually
signatures of
formed
heavier elements
stars and
like
planets.
carbon and oxygen. This was the first
A rocky,
crucial clue.
volcanic
The
moon
very
could
first
be
stars,
orbiting a planet
the
more than
so-called
600
population
light
3
years from
stars,
Earth.
would have been born from
Exomoons,
pristine
or
gas,
moons around planets
untouched by
outside our
previous
solar
generations
system,
of stellar
are
fusion.
likely too
They
small
would show no
to see
sign
directly.
of metals, the
But
astronomical term
astronomers
for
think
all elements heavier
volcanic
than helium.
exomoons could
Their
make
presence in a
themselves
galaxy's
known
spectrum
by
would
creating
suggest it was
massive
already
clouds
enriched by
of
earlier
volcanic
stars,
gas.
meaning that star formation
A new
had begun
study
even
looked at
earlier
a
than the
large
galaxy
sodium
itself.
cloud discovered in
weeks, data
2017
streamed back from
near
Webb,
the
filling
exoplanet
servers on Earth with
49b.
numbers and curves that scientists
Scientists
began
found
to decipher.
evidence that the cloud is
The
not
results were
produced
both
by the
thrilling
planet
and
or
frustrating.
the star it orbits.
Some galaxies seen at
Instead,
redshifts
the
above
motion
10
of the
were
cloud
indeed
suggests
chemically
it
simple.
originated from
Their
another
spectra hinted
object,
at the absence of metals,
possibly
marking
a
them as possible
volcanic
homes of
exomoon.
population 3 stars.
To get to this
But others,
conclusion,
equally
researchers
ancient,
used a
showed surprising
telescope
levels of
on
heavier
Earth
elements,
to observe the silhouettes
suggesting
of
that
the
the
cloud
universe's
and
first
the
stellar forges had
exoplanet
already
as
lived,
they passed in
died,
front
and
of the
seeded
star.
the cosmos within the first few hundred
In
million
one
years.
observation, the
This
researchers
contradicted
saw the sodium
expectations.
cloud moving
Models
faster
had long
than the
predicted
planet
that the
and
first
away
generation
from
of
Earth.
stars would dominate for
If the
hundreds of
cloud was
millions of
coming
years
from the
before their remnants
exoplanet, the
enriched the
scientists would
surrounding
expect it
gas.
to move toward
Instead,
Earth.
Webb seemed to be
They
showing a
think
rapid
this means
cycle of
the cloud
creation
was
and
coming
destruction,
from a different
as if
source,
the early universe
like
was in
an
a frantic
exomoon.
hurry to make complexity.
Jupiter's moon Io also
then there
spews
was
a
the puzzle of
volcanic cloud
scale.
into space.
Some galaxies
It
were
pumps
small and
sodium,
irregular, as theory
sulfur, and
predicted.
other gases,
But others were
creating a
unexpectedly
massive
massive,
cloud
containing
1,000 times
hundreds of
wider than
millions,
Jupiter.
even billions of
Io has
stars,
volcanoes
far
because
earlier than
Jupiter's
models
gravity
allowed.
squeezes the
It was
moon's
as if the
interior,
seeds of the modern
heating it.
universe had germinated
Scientists
almost
think
immediately after
WASP-49b's
the Big Bang.
gravitational squeezing is
The
likely
investigation
even more
deepened further
intense
through the
and
use of
may eventually
gravitational
cause
lensing.
its exomoon
In
to
certain
disintegrate.
regions, massive galaxy
While more
clusters acted
observations
as
are
cosmic
needed to confirm the
magnifying glasses.
existence of this
Their immense
exomoon,
gravity bending
what
and
researchers have
amplifying the
found
light from
is
objects far
promising.
behind them. Webb's infrared vision, combined with this natural
On Earth, when we
lensing,
look into
allowed
the
astronomers
sky,
to see
we use our
galaxies even
ears.
fainter and farther than would
Can't
otherwise
see,
be
right?
possible.
If you're working with X-ray
In
light,
these
no human
magnified
naturally
images,
can see
some
X-rays.
candidates emerged
That's why
that
we
could be
have
among
these
the very
telescopes.
first
It'll
star
do that
clusters
really
ever formed.
hard work for us.
Brilliant,
so it's all about
compact
translating
knots of
something
light
you
from an
can't
era when
see into
darkness
something
still
you can
ruled most of the
experience.
cosmos.
Let's
To
listen
confirm
to
such discoveries
your
required
rendition of the
painstaking
center
work.
of our galaxy, the
Spectroscopic
Milky
confirmation
Way.
of extreme
And then
redshift
tell us
galaxies
how
was a
you put
slow,
that together.
delicate process. Each potential detection had to be tested against false positives, For instance, dusty, nearer galaxies whose light could mimic the redness of
This is a very
high
classic
redshift.
image. It's, of course,
Webb's
our
unprecedented
home galaxy.
resolution
We're
helped,
looking at the
but
inner,
the danger of
about
misinterpretation was
400
ever
light-year
present.
region around
Meanwhile,
the
theorists
supermassive
began to
black
update
hole,
their models
Sagittarius
in
A
real
star, at the
time.
very core
Some
of
proposed
the
that the
Milky
first
Way.
stars might have formed in dense, massive halos of dark
And
matter earlier than
particularly as
previously
you
imagined.
approach the supermassive
Others suggested
black hole,
that
as you
cosmic inflation
skew
might have
across
left
the
behind
image from
subtle
left to right,
variations in
you'll
density
hear there's this
that accelerated structure formation, and some dared to whisper that perhaps the standard model of cosmology itself needed revision, a prospect both exhilarating and unsettling. Through it all, the telescope kept watching. One of the most ambitious programs,
So
the
for this
JWST
piece, we wanted
Advanced
to
Deep
be able
Extragalactic
to
Survey,
hear those individual
began to produce
things,
results.
right? So
Observations
the
of
X-rays from
galaxies at
Chandra
redshift
are
of 13
like
and beyond hinted at
harsh brass
incredibly
sound,
intense star
and the
formation
optical light
rates.
from the
In
Hubble
some
Space
cases,
Telescope
enough
would
to
be
double
like
the
the
stellar
lighter
mass of a
strings.
galaxy in just a few
And the
million
infrared
years.
data from Spitzer,
In
which
the
is
language
the
of the
lowest
cosmos,
energy
that is
material,
the
that
blink of
is
an
like
eye.
soft
These
movements
findings
of
carried
the sun.
implications far
So
beyond
there's a lot
astrophysics.
going on.
They
You
touched
can't
on the story of
include other
everything that would
senses
come
as
after.
well.
Ancient
It
times.
was in the hearts of those
And
first
the
stars
galaxy
that the
in
elements of
all
life
its
itself were
glory.
forged.
Starting
carbon
with
in our
planet
cells,
observing
the
for this
oxygen
month,
in our lungs,
find
the
Saturn and
calcium in
Venus
our
in the eastern
bones.
sky during
All
a
of it
couple
was
of
made in
hours before
stars,
dawn each
and
morning
the earliest
throughout the
ones
month.
began this process in the
Saturn
universe
rapidly
still finding
climbs
its
higher
shape.
in the sky each
And
day
so
as the
the
month goes
investigation
on.
was not only about
You'll
distance
find the
or
third
time,
quarter moon
it was
next to
about
Saturn on the
ancestry.
19th,
To
and
know
a
these
crescent
first
moon next
stars
to
was to know
Venus
the
on the
beginning of our own
22nd.
story.
Mercury
Yet the more
pops up
Webb
toward the
saw,
end of the month.
the deeper the
Look
questions
for it
became.
quite low in the west,
Were the
just
first
as the glow
stars
of
truly
sunset
the
is
titans we
fading.
imagined?
It's highest
Hundreds
and
of
most
times
visible
more
on the
massive than the
27th.
sun, burning for
Mars
mere
is still
millions of
visible in the
years
couple of
before
hours after
collapsing in
sunset
cataclysmic
toward the west,
explosions.
though it's noticeably
Or was the
fainter
early
than it was
universe
in
home
early
to a
May.
surprising diversity
Over
of
several
stellar
days
types,
in mid-June,
forming in
Mars
ways we have yet
passes
to
quite
understand?
close to
Could there have
Regulus,
been
the
pockets
bright
of star
star at the
formation even
heart
before
of the
the cosmic dawn
constellation
officially
Leo,
began?
the Lion.
In laboratories
Have a
and
peek on the
observatories across
16th
the
and
globe,
17th with
teams
binoculars
pored
or a
over the
small
data.
telescope to see
Every
them as
spectrum,
close as the
every
width of the
faint
full
pixel
moon.
of light was a clue, a fragment
June
of a
means that
narrative
Milky Way
billions of years
core
in the
season
making.
is here.
The excitement
This is the
was
time of year
palpable,
when the Milky Way
but so was the
is
sense of
visible as a
standing on the
faint
edge of a
band of
vast
hazy
unknown.
light arching
The
across the
telescope
sky
had done
all
its job.
night.
It had
You
shown
just
us
need
the
to be
light
under
of the
dark
first stars,
skies, away
but
from
that light
bright
carried
city
with it
lights to
riddles.
see it.
riddles that
What
no
you're
single
looking at
image
is
or
the
measurement
bright
could
central
solve.
core of
The
our
deeper
home
the
galaxy,
investigation
seen
went,
edge
the more
on
it
from our
seemed the
position
universe was not
within the
merely offering
galaxy's
answers.
disk.
It was
Long
inviting
exposure
us into a
photos
dialogue.
make the Milky
And
Way's
as
bright
Webb's gaze
stars and
continued
dark
to sweep
dust
across
clouds
the
even
sky,
clearer.
It became
And
clear
while
that the
our
next
eyes see
chapter
it
in
in
this
visible
story
light,
would not be one
NASA
of resolution,
telescopes
but
observe
of
the galaxy
escalation,
across the
of
spectrum,
mysteries deepening
peering
beyond
through
what we had
dust to
dared
help
to
us better
expect.
understand our
In the
origins.
vast theatre of the cosmos,
However you observe
the
it,
James Webb
getting out
Space
under the Milky
Telescope
Way in
stands
June
as
is a
silent
truly
sentinel,
remarkable way to
gazing backward
connect
across
with the
13
cosmos.
plus billion years.
June brings
Each
the
image it
summer
captures is
solstice
not
for
merely
those
a
north of the
snapshot,
equator, which
but
is
a
the
portal
winter
through
solstice for
time,
those south
an
of the
arresting
equator.
glimpse into the
In the
universe's
northern
earliest
hemisphere,
chapters.
this is when the sun
In
is
the
above
hush
the
of cold,
horizon
golden
longer than
infrared,
any other day, making it the
JWST has
longest day
revealed
of the
something
year.
that shatters the
The situation is
expectations we once
reversed for
held
the southern
dear.
hemisphere, where it's the
Across
shortest
fields
day
of
of the
seemingly
year.
empty space,
Earth's
swathes
tilted
of
rotation
faint
is the
reddened light
culprit.
begin to take
The tilt
form.
is always in the same
Galaxies,
direction,
as they were
with the
just
North
200
Pole
to
always
300
pointing
million
toward
years after the
Polaris,
Big
the
Bang.
North Star.
According
Since
to the
that tilt stays the
painstaking models
same
of
year
cosmic
round,
evolution,
when we're on
these
one side of the
primordial
sun in
structures should
winter, the
scarcely
north part of the
exist.
planet is tilted
Instead,
away
they
from the
appear as
sun.
fully fledged
But 6 months
edifices of
later, the
light,
planet moves
more
halfway
massive and
around
more
its annual
luminous than any
path,
theory
carrying
dared
us to the
predict.
opposite side of Earth's
Astronomers
orbit,
peer
and the
at
northern
these
part of the
cosmic
planet
infants
now
in awe.
finds itself tilted
Galaxies that
toward
should
the
still
sun.
be gestating appear
June
already
solstice
robust,
is when this
their
tilt is
nascent
at its
stars burning
maximum.
with fierce intensity.
This is summertime for the north,
These early
bringing long
revelations
days,
ripple through
lots
the
more
scientific
sunlight, and
community like
warmer
a shockwave.
temperatures.
Each
The June
candidate
solstice
galaxy
marks a
detected in
precise
this remote
moment in
era
Earth's orbit,
hints at a
a
universe that
consistent
awakens with
astronomical
urgency.
signpost that
In one
humans have
silent
observed
postage
for
stamp of the
millennia.
sky,
Ancient
one of
structures from
JWST's
Stonehenge to
famed deep
Chichen Itza
fields,
were built
dozens
in
of these
part
ancient
to
objects
align with the
crowd into view,
solstices,
each one
demonstrating how
challenging the
important these
notion
celestial
that
events
star
were to many
formation was
cultures.
sluggish in the
So
cosmic
whether you're
dawn.
experiencing long summer
What has
days in
taken
the northern
billions of
hemisphere
years in
or
our
the brief
simulation
daylight
seems to have
hours of winter in
unfolded
the
in a
south,
cosmic heartbeat.
find a quiet spot to watch
Attention
the sunset
deepens
on
when we
this special
consider
day, and
population
you'll be
3 stars,
participating in one of
theoretical,
humanity's
primordial
oldest
beacons
astronomical
composed
traditions,
entirely of hydrogen
connecting you
and
to
helium,
observers
free
across
from the heavier
thousands of
elements
years of
that
human
form only
history.
after generations of stars die. These stars, unseen and untouchable until now, have long been a missing link in our cosmic origin story. Could JWST's strange flashes and unaccountably bright knots of light be the first whispers of those forgotten titans? If they are extraordinarily rare and oddly bright. Without heavier elements to aid in cooling, such massive hydrogen-helium stars should have been short-lived and ferocious, burning bright, seeding the universe with the first heavier elements before collapsing in dramatic supernova. Yet, what we observe could be the dim echo of that blaze, fading but legible across the gulf of time. The implications of these early gleaming galaxies, or perhaps remnants of population 3 stars, extend far beyond simple annotation